Hello everyone, and welcome to Jumper Man Tech, where we specialize in HVAC, we do everything DIY, and today we have a service call for a 2-pipe fan coil unit. Thank you to everyone tuning to Jumper Man Tech. Today we have a service call for a 2-pipe fan coil unit, and that is a beautiful view of New York City. I got a service call that we have no heat. So this thermostat here, made by Honeywell, is actually a line voltage thermostat. It's 120 volts. And it is set to 75 degrees with the room temperature on 70, fan on auto. This unit has a 3-speed motor. So the unit's in here, it's in the ceiling. Got quite the spaghetti of BX cable here. I hear the fan running, but we need to see what's going on. This right here, if we look closely, is made by McQuay, and McQuay has been bought over by Daikin. Let's open up the control panel and see what's going on. It's always a crazy mess inside there, so before anything, I'm gonna shut the power off. I hear the fan running, and that is the switch for it. Let's open this up. There's always such a mess in here, and I've seen burnt wires and connections that were like without wire nuts and stuff like that, and that's just a bit sketchy. This one, actually not so bad. Let's take out this relay. Let's see what we got here. All right, let's turn this switch back on. There's a relay here, it has 2 lights, LED lights. So when one is lit, that means that one is energized. So let's see, this is a 2-pipe fan coil unit. So I gotta see what season are they in. So right now, I believe, even though it's cold outside, I think the chiller's still running and cooling. So they use water for cooling. So if they call for cooling, if it is cold, and even get in there. If you guys look inside right there, covers off, but there's like a little motor there. That's an actuator, so it's an electric water valve. So the water valve will open if you call for cooling. See, one light came on. I heard a click. Anyways, in cooling, that water will open, circulate through, and the fan blows across the coil, which is cold because it has cold water in it, and you're done. But there's supposed to be some kind of pipe sensors in here, okay? So let's say the water's cold and you call for heating. It's gonna sense the temperature that, oh, it's cold. Let's not open the water valve because we'll actually get cooling instead. And let's redirect the power to an electric heater that's in here. And there's a relay here that energizes that. So let's see if that pipe sensor is operating properly. And just so you guys know, if we had hot water, okay, if we were producing hot water now, what would happen is that the sensor would feel that it's called an automatic changeover switch. I call it pipe sensor. You know, do what you want with that information, but it senses temperature on the pipe. If they felt it was hot, it would not turn on the electric heaters, and it would open up the water, because now we got hot water. It will circulate through the coil, the fan blows across it, and we have heat. Let's see what's going on. Okay, so we have a light here, relay number 2. One is on this side. So this is lit. That means this is energized through our thermostat, but it goes through the pipe sensor first. Is it working properly? A couple things to note of, right? Of course, this meter is not turned off properly. So right now, let's check voltage. 0. So a relay has a coil, and it has points. Could be normally open or closed. This one is the coil. I'm putting my lead across. Let me get in there so we can see the meter, hopefully. Make sure I'm getting a good contact here. You see that? 120 volts. So that tells me that the water is cold, because it's sensing that, and the pipe sensor, the automatic changeover switch, is sensing that the water is cold, not to open the valve. But to redirect that power to energize that relay and turn on the electrical heaters. Okay, this thing is live right now, so let's be a little bit careful. This thick wire right here is the electrical heater, the other side of that thing, the relay. I could have sworn I just saw amps there. Yeah. So it's sending power to our heater, but we got no amps. Sad story. I hope you all can see. So there's 2 wires for the coil. When I go across it, let's get a good reading. Right there, I have 120 volts. Then I got 2 wires on the contacts, but here is normally open. When I go across, I got 0, but from each one to ground, whoa, I hope you guys can see it, 120 there and 120 there. It's a switch. So across you got 0, that means if there's no voltage drop, so it's passing through. And if you check, there's power going to that wire. And the next thing is if you check across there, we're not pulling amps. So it's telling me the system is working the way that it should. It's just this heater's not coming on. Is the heater faulty? I can't say for sure yet. There's also a limit switch on there. Okay, let's take a look at the filter. It could come down to maintenance. Let's pull this out. If this is really dirty, and it's not, it's pretty clean. But who knows when they changed it, you know what I'm saying? We gotta get some ratings. I'm gonna turn off the power. We're gonna open up this section here because over here is the blower section. Take that off. Oh, and they got some random screws there, so people have been here. 2 Phillips. Let's get 2 Phillips. Let's open that up and see what's going on. Problem is, the electrical heater can only be found if you remove the blower, and it's ridiculous. This is one of my main customers. Gotta do right by them, so I gotta do everything that I can to get this going for them. Woo! Sheesh. Alright, usually when there's 1 screw there, it'll be alright. Anyways, do right by them. And also, I don't know about you guys, but I'm trying to buy me a house. Leave a comment below if you're trying to buy a house. So, let's do everything we can. Take this thing out. Okay. Let's see what's going on. I don't know, hopefully you guys can see, but there's really thick wires. So you know that's for your electrical heater. 1 is here. I got the power off, guys. I'm gonna pull that off right here. That's 1 there. And this neutral wire is the next big one. I can check resistance across, but I can't fully see, which I don't like. And of course I'm getting a million phone calls. Hopefully it's not another service call. Looks like a 120 volt system. Let's check continuity. Let's put the 2 together. My meter does continuity and a resistance at the same time. Do we have a resistance reading? $13 kilo ohms. I'm sorry, 13 ohms. But it's not getting amps when it's getting power. It might be the limit switch opening and closing. We gotta get in there. See, now it's, you know what? Now it's showing that there's continuity and there's resistance. You know what? I could have sworn I saw amperage. It probably starts and that limit switch is cutting it off. Let me put these wires back. Let's have the meter ready and see if we can catch it right away. If so, it's gotta be the limit tripping it. Let me turn this back on. Let's make sure this display comes back on and we're back in heat, which it shouldn't have changed. Auto. I'm just gonna put this for sure on heat. Raise that up. Put the wires back, neutral to the neutral, and this is the hot line that feeds the heater. So let's see. It should at least start. Voltage is going to it. The relay is, you know, energizing. I mean, unless we lost the neutral. Right there, look, it's pulling amps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, light is on, 12, 13, 14, 15, 16. I'm counting down to make sure when does this shut off? This thing must shut off. It was just working. I mean, it was just not working. We didn't have amps across this. Sometimes this comes on and there's water squeezing through the actuator, so it seems like nothing's happening. Is it gonna shut off? I feel like we should keep an eye on this for a little bit. Why is that happening? Now it's staying on? This thing is playing games or what? This heater, everything is working. Well, I'll let that run. Oh, can't really see in here. I'm gonna put my hand in here and see if the water's open or closed. No, the actuator's closed. Oof. Uh-oh, no. Let me get out of here. That's freaking asbestos, man. Oh. Look, right there. It's dropping out 0 amps. It's probably that temperature sensor. Is it really getting that hot? I don't know. Unless the thing is bad, but yeah, at this point it's worth checking. It's gonna be hard for me to get in here because this is quite the mess. So what I'm gonna do is, hopefully I have enough slack on this BX inside here. But if you see 1 and 2, see the 2 screws? So there's 2 screws there, and then there's 2 screws on this side, very tight. So you're gonna have to get your extension. Okay, take those 2 off, and it sits on a lip. So you pull it up and pull it back, and we'll be able to move that motor, and then we could see what's going on inside that heater. We might wanna, we might wanna see what's going on with that limit. It might be, you know, failing prematurely. That's, come on, after like 60 seconds, the fan is running. If the fan doesn't run, sure. We also want to make sure everything's going the right way, or if they put the blades the right way, because sometimes these guys don't know what they're doing here. But it doesn't look like that motor was changed anytime soon just because of the dust on it. Here's an idea of what I have to do. I gotta go around this lip with an extension to try to get in there. So I'm holding it with one hand anyways. It's 1 screw. We gotta get the other one. Oh man, whoever did this, I hope you have a bad Christmas, man. Okay, so I got the screws off. What's going through my mind right now is the limit switch is obviously tripping because we had continuity across. It was closed at some point and reset, and seems kind of normal. The resistance rating for that voltage. It's different for the 208 electric heaters. So maybe, well, 100% the limit's tripping. But why is the limit tripping? Is that coil packed of dirt and we don't have good airflow? It's quite a possibility here. Or it could be faulty. So my guess would be, if it is dirty, clean it and replace the limit if I can. So if you guys can't see, Don't complain about it, because I can't see either. Aye. Okay. Push this back. Can I get in there? Kinda. Oh man. I can't really get in there. I might need to take off this here just to pull it back a little. Seriously, this is insane. Okay, so I took out one screw for this metal plate, so I get some more space in there. You guys are gonna get the first look, because I can't even see in there. Can't even get my head in there. How's that coil looking? Dirty? I don't know. I gotta see how to take some pictures. But here's electric coil, and right there, see right where I have my little finger, you see the circle piece, that's the limit switch. All right, so the coil is pretty dirty, but we should still have airflow. The last chance here is to change the limit, clean this thing up a little bit, and see if it holds. If not, new heater, new limit. But this is their last chance. Everything else is actually working accordingly. All right, guys, I just came back from the supply house and I was able to find a limit switch pretty close to it. It's just a 10-degree difference. So this one cuts out at 160 degrees. The one I got cuts out at 170. I'm totally fine with that. So over here is the heater. And where are the screws for that? Right here. You can see right here is one screw, and the other one is right there. You take those two off, that heater comes apart, and we take off 1 and 2 wires. Let's pull that out. Let's change that limit while we have this all open. Let's brush down the coil, blow that thing out, and definitely we gotta check rotation on this fan. Sometimes these blades are upside down, and actually those blades are filthy. You got poor airflow, you're gonna be burning out and damaging. And poor airflow because the blade is dirty or the fan doesn't work, and dirty filters, and I constantly find dirty filters here, to be honest with you. All right, we got 2 5/16 screws here. Let's pull that out accordingly. One here. Oh man, everything is in my way. And then this one. Let's get a picture of where the 2 wires go, and we'll pull this thing out. Okay, here's the heater. The red wire, the hot wire, comes back here. It goes into the limit switch, out of the limit switch, into one side of the heater, and then it comes back through here, neutral. This thing is filthy. Definitely needs to be cleaned. And here's our limit switch. Cuts out at 160 degrees. This is a 1 kilowatt, 120 volt electrical coil. Let's get a better view of the coil in there. Yeah, that is pretty dirty. You already know they don't change filters really well if the coil is that dirty for the electric heater and for this hot water or chilled water coil. So we're gonna brush that down, clean it up. You know, you blow it out. I have like a little electric air blower, and we'll brush down and clean up the electrical heater. It's pretty bad. And then we can change the limit switch and check airflow. I mean, come on guys, look at this. I'm just gonna brush this off. I already got a ton of dust on the floor because just rummaging in there. So I'm gonna brush all this off, because every time I turn on the heat, they smell like a burning smell. And guess what that is? That's just dust. You're burning off the dust. Anyways, let's just brush this off nicely. Make sure this is clean. Clean up the floor after. There's also housekeeping that will clean up after me. This is a hotel. Okay. And that already looks better. So let's brush this thing all up. Okay. This is a soft brush. Let's change this limit switch. I don't trust it anymore. Believe it or not, guys, these heaters and these limit switches are about almost 20 years old. And that relay is 20 years old, man. still doing its thing. Meanwhile, you buy stuff now, doesn't even work the day you put it in. They make everything like junk now. So, it is what it is. But wow, that is so much better. All that stuff leads to overheating. I mean, listen, if that dirt is on fire, that's just adding on to the heat there. Coil's dirty, you're not gonna move as good as air as we want. I mean, come on. This thing is almost brand new now. It's just 20 years old. All right, guys, I brushed it down, and I hate to do it like this, but my vacuum is literally broken right now. I'm gonna use this, blowing this thing out, man. All right, guys, that already looks 10 times better. Awesome. And the heater is clean as well. It really is. So there's just 2 screws here. 1, 2. And this switch is free. That's out. Then we can put 1 here. Screw it in. 1, 2, done. Connect this, make sure you got a tight connection. Pretty good. And that's how easy it is, but to get to it is a nightmare. I always like to update these relays as well. So if you look here, look where the thread is, here. So that means you gotta get to the screw above. That means you gotta take out this whole blower assembly just to change this relay. So I'm gonna take that off and replace that while I'm here. Here's that relay. Okay, I've seen a lot of them burn out and tons of them fail year after year. So I'm gonna replace that with a contactor as I have space. This is a 2-pole contactor with a 120 volt coil. Also, the screws will come from here, so if you ever gotta change it, you don't gotta rip this thing apart. Honestly, I find this a lot better. These 2 wires are the coil, and these 2 wires are the normally open contacts. Here, it is a little bit different. So neutral just goes to neutral. So we kind of just got to use 1 pole of this. Here and here is the coil, and then 1 wire from here will come out this way. So I'll show you guys that, but let's throw this thing in there while I'm here. All right, guys, so we have 2 contacts here. This is normally open contacts. And then we have the coil here, which is for 120 volts. One side always goes back to neutral, right? And then when we get the signal from the changeover switch that we want heat, electric heat, this gets energized, goes through the coil, it gets energized, right? And then completes the circuit to neutral. Once this energizes, these 2 close. When this is not energized, they're open from each other. So basically, when this energizes, these 2 contacts, they touch, and it sends power to the heater. In this case, 1 wire for the coils here, and the other wire is there. So when that coil energizes, this right here, this plunges in and sends power from here to here. So those 2 touch, and then it goes this way. It sends power through here into our heater, into that red wire, and back from the red wire goes to neutral and completes the circuit, and now we energize the electric heater. Let's put that heater back in. My head is right at these wires, so it's really hard to get this camera angle, but we got the contactor in, and I put the 2 screws on the side here because I don't want it to hit the heater. But the heater is back on, coil looks pretty clean, the heater looks clean. Let's put this fan motor back. Let's just make sure the rotation for the fan is correct and the blades are clean, and from there, this is the best we can do. Also the filter, and of course, the filter is clean. Let's see what I can record from here, but pretty much there's like a little lip on there, and we're gonna try to get that. Oh man, my camera's hitting the thing. Let me see if I could do this. This thing is seriously a mess.
2,000 years later.
I'm not gonna lie, guys, that was a struggle. I got it on the lip so we know we're mounted properly. Now we just put the 2 screws here and 2 screws there, and that's back. 4 screws are in. Now over here, there's 2 screws there, and we can get this plate out. That blade is insanely packed. Oh gosh. 2 screws off. Let's make sure this thing's going the right way, but my lord, is that thing dirty. So that's gonna be airflow. Oh God. Yep. Pretty bad. And then this side, they're still moving some air, but man, that stuff is dirty. And just brushing it down. Oh my gosh, man. Why did I choose this industry, man? Sometimes it's like, oh, what did I do, man? It's a love-hate relationship out here. Whew. Guys, I know, the mess I'm making is ridiculous, getting it everywhere, but man, if this is coming out of your blower and your coil, I mean, come on, man. This is just, it's one of those days, man. It's one of those days. Hey, it ain't perfect, but that's the best you're gonna get with the brush without pulling this whole thing apart. It needs some serious maintenance, but that is definitely gonna give them airflow. You can see. Also, I want to see which way this turns so I can make sure that this fan blade is put on properly. Sometimes these guys change the motors and the blade is put on backwards. Let's see, I'm gonna have to put it in heat so I can check the fan speed. We want to make sure that we get a fan speed in each setting: low, medium, and high. Okay. Dusty. The rotation is correct. Let's go to medium. I can smell the heater. Medium, got speed, high, and high. Let me shut this off. I heard that click. That means our contacts are engaged. Everything's looking good. I can smell the heaters on. So let's close this all up and make sure this thing stays on. All right, so everywhere you see some black tape on there is because there was some red tape that was really all just falling apart. So I kind of just sealed all that up. I got my amp meter across the wire that feeds the heater. All right, and when this plunges in, you know that the coil was engaged and it's sending power to it. Let's just hope it stays on. Also, put these covers back. Everything's back to normal except for electrical, just because I want to test it and see if it stays on. And let's see what happens. All right, guys, we're pulling 8 amps. It's 5:37 right now. Let's see if this stays on before it cut out in less than a minute. There you have it, guys. The heat is staying on. Before, it was tripping with a high-speed fan, so you're trying to move even more air at that point. I got it in medium, and it's been over about 13 minutes. All right, we got heat. All right, guys, it's been another 10 minutes. You know, this thing was tripping after a minute, so for the fact it's been running for over 20 minutes, you could probably assume that things are good. Next time someone says maintenance is a scam, send them this video. Here's a supply air grill, and we have a thermometer inside there. Check it out. 69.8 degrees. It sounded like water was squeezing through the actuator even though the heat is on. Let's manually close the supply and return water valves and see if this temperature rises. Even though we got the heat back up, looks like they got other problems here. I'm in the ceiling outside the room. They got these water valves. Let's see. I'm gonna get that. Let me see if I reach it. Yes. Right here. So you see, close this one. And I closed this one, I don't know if you can see. And those are for the 2 pipes right there entering the room. So we closed the chilled water. Wow, look how fast temperatures go. 88 degrees. Alright. Even though the actuator I felt was closed by hand, like you can feel the stem on it, water's still squeezing through, so the actuator and the actuator valve gotta be replaced. Alright, beautiful. So, how are you gonna change the actuator? It's back behind there, if you can see it, the little silver thing on the valve. You're not brazing that. And there's a beam here. You can't even make a hole on the other side of this wall. So, give y'all a little insight as far as to what I do. Further down the line, I find the same water pipes, where this case is right here. And what I do is that I pipe in an actuator where I actually have space, leave the other one propped open, and run a wire so it can be controlled through this unit, through the thermostat. But I'm gonna have to find a different location for this. Unreal. So the only option is, man, if I could even get this camera up here, it's maybe this pipe here. This is a drain, but this is one of the water lines to get it on the side there, but the freaking drain is in the way too. Sounds like a crazy thing, but I might need to make a hole in here a little bit more and run the wire in there and see if I can do it in the hallway. Oh, it's gonna be tricky working with this thing in the future if it ain't gonna be me. All right, guys, the heat is staying on now. So even though we repaired the heating problem, now they have a problem where the heating and cooling is mixing. And that is because even though the actuator shows that it's closed, water is still squeezing through. Listen, this thing is really old. Let's see real quick if you can see it here. Is there a date on this unit? A lot of these show me the date. Does it say? Yes. December 2005. Next month will be 2025, so got over 2 decades. Yep, that'll do it to you. I'm lucky this thing even lasted this long. So we're gonna have to come back and figure out where to pipe this in. Look at this freaking mess, man. I don't think we can get to that. We might need to go into the hallway for this one. Ooh, that is not fun, man. It's kind of ridiculous, but that's the only way they're gonna get this thing to work, unless they want to replace this unit. And with all that beam and everything in the way. Look, there's a pipe here, and there's a beam there. Good luck, my friend. And unfortunately, that would be me. But that's not gonna happen. They're gonna change that valve. I already know. I changed a bunch of these already. But this is what separates you from a technician and a good technician. You gotta go the extra mile here as far as doing everything you can, and then making sure you properly test this. So even though we got the heat running, now we found another problem, and that's another way you make more money. Because like I said, I'm trying to buy me a house, and these McQuay units pushing me towards that that goal. But anyways, we're gonna wrap this one up. I'll record the next video, and if anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.